Hello everyone and welcome back to Nunley Math. I'm your host Aaron Nunley. Thank you so much for joining me here today as we continue our discussion of the surface area of prisms and cylinders. Now in our last video we spent a considerable amount of time talking about how when we're looking at the surface area of a rectangular prism we have two rectangular bases and all the other sides were rectangles, and we talked about the fact that if we want to find surface area we just simply need to find the area of all six rectangular faces and then add those up to see what it takes to cover the entire surface. We're going to take that same kind of an approach today as we begin our discussion of triangular prisms. Triangular prisms. And just like when we were working with our rectangular prisms, we're going to start off with the shape of the base, which is a triangle. We're going to ask, how many squares does it take to cover this triangle? Now, in order to help you with that, I am going to go ahead and give you some dimensions, 4 inches by 3 inches. And I want you to think about how many squares it's going to take to cover that. Now, if I try to fill this with inch squares, that's squares that all measure 1 inch by 1 inch. You're going to get them to fit really nicely over here, but eventually you're going to run into a problem over here on the right because whatever this last square is over here is going to be partially inside the triangle and partially outside the triangle. Your only other option is to stop your row of squares over here and have part of your triangle not cover. When we talked about our area formulas in a previous lesson, we said that the way we resolve this is rather than thinking about how many squares can fit inside of one triangle, we think about how many squares would fit inside of two congruent triangles that are stuck together. Because if I take these two triangles and I stick them together, it forms a rectangle. Now, I don't have time to go into all the different possibilities for different shaped triangles, but suffice it to say that any triangle, if you pair it with a congruent triangle or a triangle of the exact same shape and size, can eventually be turned into a rectangle. Sometimes they have to be turned into parallelograms first and then turned into rectangles, but that's not our topic of discussion for today. So, once we have it in rectangular form, it's now much easier to see how many 1-inch squares it would take to fill the object. Remember, an inch square or a square inch is just a square that measures 1 inch in two different directions. And hopefully when you look at this, you can very quickly see how many it's going to take. It takes 4, 8, 12 squares in order to cover these two triangles. So if it takes 12 1-inch by 1-inch squares or 12 square inches to cover the rectangle, it must take half of that to cover each triangle. In fact, we learned in our area unit that that's where the formula for the area of a triangle comes from. It says, hey, if I can find the area of this rectangle by doing the base times the height, or 4 times 3, then I can find the area of the triangle by doing half of that, or half the 4 times 3, which means if it takes 12 to cover the whole thing, it's only going to take 6 to cover each triangle. Now, keep in mind that this is a lot of partial squares, but when we rearrange these, or if we could rearrange these and stick the pieces together, it would occupy the same space as 6 of them. Here's the question. How many squares did it take to cover this triangular prism? Now, when we covered a rectangular prism, we remember that a prism has two parallel congruent shapes by which it gets its name. This happens to be a triangular prism, so I know there's a triangle in the front, and I know there's a triangle in the back that I can't see. And then those two triangular bases will be connected by 1, 2, 3 rectangles. 3 rectangles. Prisms are always 2 polygon bases connected by rectangles. The number of rectangles is the same as the number of sides on the base. Now I know that's probably fairly difficult for you to visualize, so what I'm going to do is I'm going to hop out of this PowerPoint and I'm going to hop into a program or app called Shapes that I picked up from shapes.learnteachexplore.com, and we'll take a look at this as a 3D figure that we can manipulate. So here we go. We're going to hop out. It's going to be like magic. So here we are inside of the Shapes app. You'll notice here across the bottom there are lots and lots of different shaped prisms. Each picture gives me the shape of the base. So what I'm going to do is I'm going to grab this right triangle over here. This is a right triangular prism, and I grabbed it because this is the one that looks most similar to the one we are working with currently in the PowerPoint. I'm going to see if I can flip this and rotate it just a little bit so that it looks a lot like what we were seeing a second ago. Can I get it to that? This is pretty close right here. There we go. So you can see that this is a triangular prism. I'm going to grab some paint colors. And I'm going to paint this bottom side, or this one side of the triangle red. I'm going to paint this other side over here red. Those are our two triangular bases. And you can see as I spin this around and paint the other sides green, that you have a green face here, a green face here, and a green face here. And notice those are all rectangular. Remember, prisms have two bases that are the same, the triangles, and they're always connected by rectangles. Now what I'm going to do is I'm going to unfold this so you can see the net of this figure. Fold it out. I kind of like that. That's pretty cool to me. Notice here you can see the triangle, and the rectangles that connect them. Now I can arrange this a couple different ways. Let me get over here to the nets, and I can change which net we're looking at. Let me go back. There we go. I can change which net we're looking at. There's actually several different ways these nets can be arranged, but I think this one that we're working with is probably the easiest. So let me fold it back up just a little bit, and let's repaint this. Two triangle bases that are connected by three rectangles. And I can fold that up. I'll show it partially folded so you can get a better look at it. I can fold that up, and as I do, you can see that it folds back into our triangular prism. And then I think I can rotate this. There we go. I'm getting better and better at rotating this as we go. You can see that it looks very similar to the one that we have in our PowerPoint. So when we go to find the surface area, we're going to have two triangles, and we're going to have three rectangles, even though I can't see some of those missing sides. Now we do have the option in this app, when I take the faces, that I can make this hollow and see-through. If that's helpful for you, certainly we'll do that for just a second. You can now see these faces that are hidden from us when we're in the other view. All right, I'm going to hop back out of this app and go back to our PowerPoint. It's going to be like magic. Ready? Here we go. So we're back here at our PowerPoint. You will notice that we have this rectangle. You will notice that we're back here at our PowerPoint. Notice we do have the triangle in the front. We now know there's that triangle in the back, and there's three rectangles. One here I can see, one underneath that I cannot see, and one running here along the back that I also cannot see. So I'm going to create a table for that. Notice that it's different from the table I used when doing the rectangular prism, in that now I have two triangles and three rectangles. It's important to know what shapes you're working with, because that's going to tell you what formulas you need to use. Notice I copied the formula down at least once for each shape, and then I'm going to go through and calculate this. I show the formulas for three reasons. Number one, it helps me not make careless mistakes when I'm plugging in numbers. Number two, it helps me memorize the formula better. And number three, it tells other people what I'm doing if they're trying to follow my work. So let's find the area of this triangle. It has a base of 28 and a height of 21. I know that's the base and the height because they meet at a right angle. I also know that the area is going to be half the base times the height, because the base times the height would give me the area of a rectangle if I were to use two congruent triangles together, which means this triangle is going to have an area of 294. I'm going to duplicate that for the triangle that's on the back, because since it's a prism, I know those are the same size, and I'm going to work on the three rectangles. I'm going to take this one here first. This is 35 by 14, 35 by 14, which is 490. I'm then going to do the one along the back. Now this one's a little harder because I can see it's 21, but I can't see these missing sides back here. So what I'm going to do is very quickly, I'm going to grab my pen, and I'm just going to draw for you what it would look like. Remember we looked at the hollowed out view before? It would look something like that. Wow, that's really bad there, isn't it? There we go, that's a little better. And when you do that, hopefully you can see that this 14 and this side right here and this side right here are all the same. When you're looking at two-dimensional representations of 3D figures, try and find those sides that are parallel, because those tend to have the same measures. 14 times 21 gives you the 294. And then the last side, that bottom down here, is going to be the 28 by the 14. Don't be afraid, if you're doing these on paper, to highlight and trace and match things up using colored pens. I find that to be very, very helpful. That gives me 392. When I add those up, it comes out as 1,764. Now, this is one of two ways I show my students to do it. Most of my students tend to like this way. There are a few students who prefer to do it as a formula. Notice two triangles plus a rectangle plus a rectangle plus a rectangle, and then they just plug in the numbers. Here's my numbers from the triangle formula. Here's my numbers from one of my rectangles, the numbers from the second rectangle, and the numbers from the third rectangle. Notice that when I do 2 times half, that's going to become 1 times 21 times 28, gives you the 588. That's the 294s combined. And then you add all that together to get 1764. Make sure you tell people that you're dealing with centimeter squares, because you're covering this with squares that are 1 centimeter by 1 centimeter. And that's basically it. The rest of this video is going to be separate examples for you to try. I would recommend that as we do these, you try them on your own with the video paused and then restart the video. I'm going to do these a little faster than I did that first one. That first one was to give us the idea, and this is just practice. So remember, surface area is the total area of all the exposed surfaces. Since I'm dealing with a triangular prism, I'm going to set up my table exactly as I did in the previous slide. If you have not taken the time to set up your work, please do that before you begin. It's going to help you organize your thoughts. The triangle here has a base of 10 and a height of 12. Notice this 13 is here. I don't need that when finding the area of the triangle, so I'm just going to ignore it. Half the base times the height gives me a 60, and I also happen to know that there's another triangle hiding here in the back that I cannot see because the figure is solid. Now I'm going to do all of my rectangles. I'm going to erase those real quick, and we're going to start to erase it. Let's erase that, erase that, erase that, and erase that. Let's talk about the rectangles. You'll notice that for each of these rectangles, notice the bottom is going to be 10 by 14. This side right here is going to be 13 by 14. I'll draw the rest of that one. And the one on the back is going to be 13 by, from here all the way back, is going to be 14 as well. I point that out to you because you want to keep in mind that all of these triangles will have one side that is 14. The height of the prism is always one of the dimensions of your rectangle. So it's always going to be a rectangle that's 10 by the 14, 13 by the 14, and 13 by the 14. And I'm just going to plug those in and calculate them out. Notice, since this was an isosceles triangle instead of a right triangle, that 2 of the sides were the same. That causes us to have 2 rectangles that are the same measure. You can't always do that, but sometimes it's nice and saves you a little bit of computation. Again, if you're a formula person, 2 triangles and 3 rectangles, you plug in the same numbers we used in our table, and then you just compute that out. 624 millimeters squared. Once again, I would recommend pausing the video and trying this on your own. Notice that this is see-through as opposed to solid. Some students get confused by that, so I wanted to make sure that I did examples of each. I'm going to assume that if you wanted to try that on your own, you've already done so. Here's my table. Half the base times the height on the triangle. Notice this is 8 by 3. That's going to be half of 24, which is 12. Don't forget that the back is the exact same size. And then you have 3 rectangles. People sometimes get confused on this because there is no measure on this side of the rectangle. Notice it's back here. This is 5. This is 5. And even though there's not a congruence mark here, which I think is a shortcoming on the people who made this particular figure, we're going to assume that this is isosceles and this is also a 5. 8 by 10, that is the rectangle on the bottom. Feel free to trace that with a highlighter or a pencil if you're trying not to, if you're having trouble seeing the figure. I've got a 5 by 10. That's 10 here, 5. And then on the back, you'll notice that since it's isosceles, it's also 5 by 10. That one's a little harder to see. And you add all your sides together, that's going to give you your area, or your surface area. And once again, you can do this as well as a formula. Last one. This is one I made myself using the word art or the art features in PowerPoint. So it is just a little bit sloppy, and I do apologize for that. I picked it because it is an obtuse triangular prism. That means that it's built with obtuse triangles. That sometimes throws people off. Take a second and try that on your own. Pausing the video, of course, and I'm going to keep going assuming you've already done that. I still have my table. What throws people off on this type of triangle is notice that the height and the base measurements don't line up like you would normally expect them to. Even though the base has the 7, the height of a triangle is the distance from the bottom to the top perpendicular to the base. I went ahead and wrote it out here. Don't let the fact that it's written on the outside throw you off. It's still the height. That gives you a 63 divided by 2, which is 31.5. I'm going to do it again because the triangle on the back is the same size. You have 3 rectangles. You have the 7 by 11. That's the one on the bottom. Feel free to trace that or highlight that when you're working it if you're having trouble seeing it. You have this 13 by 11 across the top. I actually wrote it as 12, which was an error on my part. I'm going to have to go back and fix that. Let's do that real quick. 13 by 11, which is 143. And then lastly, you have the 9 by 11 across the back. 9 by 11 across the back, which is, of course, going to be 99. Now, when I added those up with the wrong numbers, I came up with 371. I need to add an extra 11 onto that, which is going to make this 382. I assume down here I did the exact same mistake. Yep, this should have been a 13 by 11, which makes this a 143 and makes this a 182 as well. That's all we've got for today. Hopefully that's enough information to get you guys started. Hopefully the surface area of triangular prisms is not too daunting for you. Again, take the time to make sure you're using the right formula and take the time to make sure you can see all the shapes you're working with. Don't be ashamed to go through and trace things. It's a huge, huge help. If you get a chance, make sure you leave us a comment in the comment section letting us know if this is helpful or not, things we can do to improve it. Obviously, we've got to fix those typos, and that will certainly be part of our improvement. But if you notice anything else, make sure you let us know. Turn on your notifications so you can receive any new updates we have coming out of Nunley Math. Thank you guys so much for joining us today. Wish you all the very best of luck. Take care of yourselves. Bye-bye.